In this lesson, we are going to finalize our buildings by adding rooftops to their tops. And we will also distribute HVAC units on them. We will start by using the building curves output from the building attributes node group. Let us drag off of this output and insert a reroute. You can probably already guess the routine. We press Ctrl G to turn this into its own node group. We name the input building curves and the output rooftops. Next, let us exit the group and resize it slightly to give ourselves more space. We will rename this group to rooftops, keeping the naming consistent. We then tidy up the reroute and add a join geometry node to combine the rooftop geometry with the rest of the building instances. Let us now re-enter the node group. To create our rooftops, we will begin by moving our curves to their correct height and filling them. However, we are about to encounter a problem with the fill curve node that we will need to solve. We are also going to convert these curves into meshes, using the curve to mesh node along with the profile curve. This will allow us to give the rooftops a visible lip or border around the edge of each building. So first, let us move the curves to the correct height. We add a set position node. Then we bring in our named attribute called floors. We multiply the floor count by the height of each floor, which is 3 meters. This result is used in a combine X, Y, Z node. We connect the output to the Z input, and then send that into the offset input of our set position node. We now have the building curves placed at the correct elevation. However, as mentioned earlier, we are going to run into a problem with the fill curve node. Let us test this out. Drop a fill curve node over the curves we just moved. It breaks. It does not work. The issue is that the fill curve node does not respect the vertical position of the curves. It fills everything at a flat height of 0 on the z-axis. Even if we try to move the position after the fill operation, it still does not fix it. To test this, we select the fill curve node and drag it outside of the network while holding Alt. Then place it after the set position. Note the result is the same. The curves are still being filled at the bottom. Why is this happening? It is because the floors attribute we used is stored on the spline domain. Once we convert our curve to a mesh, we lose those attribute values. If we try viewing the values before the conversion, they look correct. But right after converting to a mesh, they all turn to 0. We could try using a capture attribute node and transferring the attribute from one domain to another. But actually, there is a simpler and cleaner way to solve this. Let us wrap everything inside a for each loop. We will use the for each island node and set it to spline. Place the loop before and after the processing section. Make sure to route the generated geometry through the loop correctly. Then, from outside the loop, take this floor's attribute and connect its single value output to the multiply node. This solves the problem. Now let us assign a material to these rooftops. We add a set material node and choose the concrete material. To make sure the color stays consistent across buildings, we convert this mesh into an instance. Add a geometry to instance node after the set material. Now all buildings will use the same concrete color, keeping the rooftops visually unified. Next, let us add the border detail, the lip that wraps around the edge of each rooftop. This will help separate the rooftop from the rest of the building. To begin, we drag directly from the original curves and use a set position node, just like we did earlier. Let us make more space in this area. We will join this geometry with the other before applying the material. This way, the rooftop lip will also use the same concrete material. Now that our curve is placed correctly, we use curve to mesh to convert it. Then, we add a profile curve using a curve primitive. At first, this looks too thick and large, so we adjust the width and height. Set the height to 1 and the width to 0.5. That looks much better. As I have mentioned throughout the course, these values could be made procedural if needed. To make the edges less sharp, we use a fillet curve node. Apply it to the main rooftop curve. Switch the mode to poly. Set the count to 6 and the radius to 1. This already looks better. We can also add filleting to the profile shape itself. Let us duplicate the fillet curve node and apply it to the profile. This time, we can use a count of 3 and a radius of 0.1. Now we want to distribute our HVAC units on the rooftops. We do not need to place these inside for each loop. Doing so would be expensive in terms of performance. Instead, let us take the mesh from the set position node used for the rooftop. Drag off of it and insert reroutes to tidy the layout. We bring this output outside of the for each island loop so that we can use it separately. Then, inside the main node tree, we go to our group outputs and name these. One as rooftop instances and another as points plane. Now, let us view the points plane. The first thing we want to do is inset these rooftop shapes so that the HVAC units are not placed directly at the very edges. We will use our inset utility group to do this. At the top of the group, set an inset distance of 2.5 that should give us some margin. We may need to fine-tune this later, once we actually see the HVAC elements placed. Next, we use delete geometry to remove the boundaries. Set the type to face and delete the boundary faces. We are now left with usable rooftop zones. Add a points on faces node to distribute points. Right now, this gives us way too many more than 83,000 points. So we switch from random distribution to Poisson disk. This allows us to define both a minimum and maximum distance between points. Set the minimum to 5, and now we are down to around 313 points. You can also adjust the density factor, try setting it to 0.5 to reduce the number of points further. These are all parameters that could be exposed to the modifier panel if desired. Now we are ready to instance our HVAC units onto the points we just created. Add an instance on points node and bring in a collection info node with our HVAC collection. We need to make sure to check separate children so that each element inside the collection is treated as its own instance. Let us take a look in the spreadsheet without this option enabled. The entire collection would come in as a single combined instance. Checking separate children splits it into the individual parts. This is different from how we handled our windows earlier in the course. There, we used utility group instead of a separate children, because that method does not work when dealing with nested collections. Here, since we do not need to go into deep nested collections, this simple option works just fine. Next, enable pick instance, so that different elements from the collection are randomly selected for each point. Connect the output of the collection info node into the instance input. We now have HVAC elements appearing all across our rooftops. Next, we want to merge this new geometry with the existing rooftops. Add a join geometry node and connect both the rooftop meshes and the HVAC instances. Now when we view the result, the HVAC units are placed on top of our buildings. Let us go one step further and add randomness to the instance index. We do this by using the same logic we applied in the separate elements group. Get a domain size node and set it to instances. Then subtract 1 from the instance count and use that as the maximum for a random value node. Connect this random index to the instance index socket. Now we can use a seed value to change which HVAC unit appears on each rooftop. Now we want to add some variation to the rotation of our HVAC elements. At the moment, all of them are facing straight forward, which looks too uniform. We want to rotate them, but not by just any random angle. We do not want odd orientations like 12 degrees or 160 degrees. Instead, we want the units to rotate only in 90-degree steps forward, left, backward, or right. To achieve that, add a random value node and set its range from 1 to 4. Next, multiply that random output by 90 degrees. Since Blender expects the rotation in radians, not degrees, we need to convert 90 degrees into radians. We do that by multiplying by pi divided by 2, which is equivalent to 90 degrees. You can type this math directly into the input field. Blender will evaluate the expression. Now connect this output to a combine X, Y, Z node, with the result going into the Z input. This forms the rotation vector. Plug that into the rotation socket of the instance on points node. That handles the orientation of each instance. So that sets the multiply value at 90 degrees in radians. Now each of our elements are snapped at 90-degree intervals. We can change our seed value here and see the HVAC units rotate into different 90-degree positions. Change the seed again, and you get a new randomized but clean orientation every time. Now that our rooftop setup is complete, we want to make sure everything is integrated with the rest of the city. Let's exit the rooftop node group and connect it back to our main city layout. Duplicate the existing join geometry node and connect the rooftops to the rest of the building geometry. This joins our building elements with the rest of the city setup. If we want to preview everything clearly, we can lower the number of parks temporarily. We will handle those shortly. With this setup, we can already see a complete city layout. We can still control the number of buildings that are commercial or residential. We can adjust building height by changing floor settings. And we can edit our base mesh in edit mode by extruding new faces to expand the layout. We can automatically generate more buildings. But there's one thing to note. If we extrude beyond the area we originally allowed for in our building quarter size, no buildings will appear in that new region. So we would need to increase that parameter as well. Let's reset it to 25 for now, and just delete the new faces, so we do not exceed our original scope. There's one last detail we want to include before we move on to the parks. Earlier in the course, when we created our streetlights, we used a Boolean toggle to switch the lights on or off. We want to reuse that same Boolean to control whether the window lights in our buildings are turned on. So we go back into our building instance, is node group, and locate the part where we assign the windows. Right after instancing, we add a store named attribute node. Set its type to Boolean and assign it to the instance domain. We will call this attribute lights. We could also use a random value instead. Set it to Boolean and plug it into the lights attribute. This gives us a random distribution of lights. We can control how many are on using the probability. You can also duplicate this setup and apply it to the commercial buildings. Let's drop that in and reconnect everything to the join geometry. Now the commercial lights work the same way.